Good day, my dear 9th class students. I am very happy to come back to teach you. Some time back, I taught you the chapter number 4, that is lines and angles. I covered the most of the chapter, but we have not done any exercises. So in this class, I will review what I taught you earlier. Actually, as a matter of fact, most of that you already know, you already learned in your previous classes. So anyway, I will review and then we will take some specific problems. There are 4 exercises in this chapter. I will take one problem in each exercise, and what I will do is, next time I will select few more problems, and by that will be the end of the chapter. Before I get into the actual lecture, I want to talk to you that we have been recording several videos, and we have more than 100 videos today, and every day we are working to produce more than 4 or 5 videos covering various subjects and various classes. And I want you people to go through the videos, watch the videos with the textbooks in your hand. Unfortunately, I see many of you do not have the textbooks. You have to have the textbook. For example, in the mathematics particularly, if you don't have the textbook, you don't have the problems. Even if I taught you, unless you do the problems, you will not actually grasp the methodology or this problem solving technique or the mathematical concept. If you want to know, then you have to have the textbook. Okay? So watch the watch the video along with the maths textbook, and then more importantly, do all the exercises. So that's the review part of it. Now, so here, that's the general comments, not the review part, general comments. And in the last lecture, I talked about the lines and angles. This particular chapter, the title of the chapter is Lines and Angles. Now, when you have two lines, they may intersect. They always maintain at a constant distance, or they may coincide. These are the 3 possibilities. When you have 2 lines, either they have to intersect, or become parallel or maintain a constant distance. Just like the famous example is railway track or the bars in a window. Or you can see the edge here, the blackboard. The top edge is one line and the bottom one. These 2 lines do not meet. So those are the examples for the parallel. And there is one where the line, both of them coincide. So now when 2 lines intersect, so we will address these issues one after another. When the 2 lines intersect, this one, if you take this example, when 2 lines intersect at a point, this point is called the point of intersection, and they form an angle. Similarly, when you have an arm here, if you look at your hand and this particular part of your body, this one, and you have an angle that is formed. So similarly, when you take 2 fingers, this is one line and this is another line, then an angle is formed. These angles can be either acute, right angle, obtuse. The angles can be acute angle, right angle or obtuse angle, depending on the value of the angle. In the case of the acute angle, is less than 90 degrees. Right angle is equal to 90 degrees. Obtuse angle is greater than 90 degrees. So you can see here, this angle is less than 90. If you draw a perpendicular here, this whole thing, this is 90 degrees. That's how we represent. When you have a line and another line intersecting at right angles, then this angle is shown as a right angle. There you draw a line like that. Whereas when you have two lines like that, you don't show them like this. You show them with another, say, general notation. Okay, we learned about acute angle, right angle, obtuse. All this you know. Okay, then we also learned about complementary angles and supplementary angles. Complementary angles is if two angles, sum of the two angles is equal to 90 degrees, then the angles are said to be complementary. And you can define it like this. Two angles are said to be complementary if the sum of the angles is equal to 90 degrees. Similarly, for the supplementary, and if sum of the two angles is equal to 180 degrees, then you call them as supplementary. That means two angles are said to be supplementary if the sum of the angles is equal to 180 degrees. You see here, for example, and then we also learn about a linear pair, adjacent pair and all that, okay. So, first I told you about this is a complementary, this is supplementary. I also told you the technique of just to Bandaguttu. To remember, C is smaller because 180 comes after 90, S comes after C. So, sometimes you get a doubt. Complementary means 90 or 180. So, this is how you can differentiate and try to remember. Now, here I told you so far we learned about acute angle, right angle, obtuse angle, complementary angles and supplementary angles. There is also what is known as adjacent angle. Suppose you have a line like this is an angle. Suppose you have another line here, another line here. That's like that. There are so many angles. So this is another angle, this is another angle, this is another angle. So there are 1, 2, 3, 4. 4 angles are there. Now, two angles are said to be adjacent to each other if they have a common arm. This one we call it as O. Let's say this is A, this is B, this is C. And this is D, this is E. So, here OA is one ray, OB is another ray. They are meeting at O. O is the point of intersection. Now, OC is another ray. Here, for angle, another thing is angle, this angle 1, let us say 2, 3 and 4. Angle 1 is equal to angle AOB, and angle 2 is equal to angle BOC. Here you can see these two angles, AOB, BOC, are said to be adjacent angles because they have a common arm OB. So, for example, if you take angle AOB, and angle COD, these are not adjacent angles because AOB is this, COD is this. Therefore, there is no arm common to both the angles. So these are not called adjacent angles. And so the adjacent means pattan kuchuntam. Suppose you are sitting on a bench. You have your friend, next to your friend, there is another friend, first friend, second friend. Now, second friend is not adjacent to you. When you say adjacent, then immediate right after. Okay, so here this 1 and 2 are called adjacent angles. Similarly, 2 and 3 are called adjacent angles, and 3 and 4. Now then finally, I want to talk to you about the linear pair. Linear pair. That means when you have a line like this is a line. Line does not have any length. It's an extended one. Okay, let us take a point here, and if you draw a line, another ray here, this ray, let's say this line, you can call it a small l or A, B, and the point of intersection is O, and let's say this is C. Now, you can see here angle BOC plus angle COA. Angle COA. This is equal to 180 degrees. That's when since it is a straight line, it's also called straight angle angle. So straight line. Now, angle BOC plus angle COA is equal to 180. Then these two angles are called, sum of them is 180, then it's called a linear pair. Linear pair. Linear pair. Pair and japa. Linear and line. Line. This is the line. And the pair. This is one angle, this is the other angle. That's why it's called linear pair. And its sum is 180 degrees. Now, let us talk about we are getting to the end of the review, then we jump on to the exercises. So, next one is all this we talked about when two lines intersect. And what about the other one? I told you, when there are two lines, they can intersect, they can be parallel, maintaining a constant distance, or they can coincide, right? So let us take this case where there are two lines here. Let us say this is line L, this is line M. Or you can say A, B, C, D, and also you can mark them. Now these two are parallel lines. That means the distance between these two lines is always constant. Understand? Okay. Now, if a line intersects these two lines, then this line is called transversal. This is another line. This is L, M. Let's say this is M. This is called transversal. E-R-S-A-L. Transversal. Transversal is a line intersecting any two parallel lines. Sometimes it may intersect more than two. There may be three, maybe four, like that. But anyway, generally, when we in mathematics we restrict ourselves to either two lines or three lines. Okay. Now, when two parallel lines are intersected, now sometimes you will show it like that too, with the same arrow. Okay. Now, suppose if I draw two lines, parallel lines like this, and also have drawn lines like that. If I draw an arrow like this, that means these two lines are parallel. Suppose for these two lines are also parallel. So I want to use another symbol for that. Okay, see that? So these two lines are parallel, and these two lines are parallel. Now, let's see. So when two parallel lines are intersected by a transversal, the angles, there are several angles that are formed. There are several angles that are formed here. You can see here, this is one angle, one. Let's say this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8. How many angles are formed? 8 angles are formed. Interesting thing is, if you know one angle, we can tell all the other 7 angles. So that is the beauty of parallel lines and a transversal. All you need is one angle. So anyway, first we will consider what are the various types of angles formed. Here 1 and 3, they are called vertically opposite angles. You can see here, this is one line here, this is another line. So these two lines are called vertically opposite angles. And these two lines are equal. 1 and 3 are, 1 is equal to 3. Understand? Similarly, 2 and 4 also are vertical opposite angles. 2 is equal to 4. 2 is equal to 4. So these are called vertical opposite. Similarly, 5 and 7. 5 is equal to 7 and 6 is equal to 8. So these are called vertically opposite angles. Now, there are also called corresponding angles. See, 1 and 5. 1, 5. They are also equal. 1 is equal to 5. This one is made out of, this angle is made with the transversal with this parallel line. The same transversal with another line that is parallel to this, that angle is 5. So 1 is equal to 5, and similarly 4 is equal to 8, and 4 is equal to 8. Similarly 2 is equal to 6, 2 is equal to 6, 2 is equal to 6, and 3 is equal to 7. 3 is equal to 7. So we learned about vertical opposite angles and corresponding angles. Now, and also I want to tell you something more, and then we jump onto the problems. Now, 1 and 2, here certain angles are outside the parallel lines. They are outside the parallel line. Some are inside the parallel line. So when they are internal, then you call it as interior. They are called interior angles. Here the interior angles are 3, 4, 5, 6. They are the interior angles, 3, 4, 5 and 6. Why are they called interior angles? Because they are in between the two parallel lines L and M. That's why they are called interior angles. Then what about the outside remaining angles? They are called exterior. They are called exterior angles. So this one is one line, this is the other parallel line. These two lines are parallel. So 1 and 2 outside. Similarly 7 and 8 outside. Exterior angles are 1 and 2 and 7 and 8. So far I told you, I have reviewed whatever I taught. I think I taught all this in the last lesson. But anyway, now you are up to speed. So in this case, what I told you is, when there are two lines, the lines may be intersect, may become parallel or coincide. When they intersect, an angle is formed. Angle, depending on the magnitude, the angle can be called as an acute angle, a right angle, and an obtuse angle. Then I also told you about complementary angles and supplementary angles. Two angles are said to be complementary if the sum of the angles is equal to 90 degrees. Similarly, supplementary. Two angles are said to be supplementary if the sum of the angles is equal to 180 degrees. And then also I told you about adjacent angles. Adjacent angles are the angles, one is side by the other. They have to have a common arm. And common arm means automatically the point of intersection will be there. It is common. So that is then they are called adjacent angles. Then we have what is called a linear pair. Linear pair is when you take a line and another ray intersects a line, at the point of intersection two angles are formed, and sum of those two angles is 180 degrees. In other words, it is called a linear pair. Okay? So that's all what we learned. Now I want to move on to the problems. Okay? I hope you understood so far what I told you. Now let us see. I have selected some problems here. Well, I gave you the review. Basically, it's almost like a repetition of what I taught previously. So I brought you up to speed with all the different notations and also different concepts, different mathematical rules and all that. When I say rule, like for example complementary, I said two angles are said to be complementary. That's the way I want every student to write. Two angles are said to be complementary. If, then you indent it, put a star, then you say if the sum of the angles is equal to 90 degrees. Okay, let me move on to like I told you, I have taken one problem in each exercise. There are 4 exercises. One problem 1395, like that I have written down here, and I am going to address those. And in the next final version, that is part 3. In the part 3, I will take another maybe 8 or 10 problems, depending on the time availability, some of the other difficult problems, and try to solve them for you. But you have to do it yourself. నేను చేసినప్పుడు బాగానే ఉంటుంది, అంతా ఈజీగా కనబడుతుంది. But when you try to do it, then you will see the difficulty. You may not see the difficulty if you follow the video very well, put your 100% concentration. It should be a piece of cake. Mathematics, I want you to enjoy. Srujana students enjoy mathematics as a very interesting subject, and they won't prepare for the examinations, because it's already by the practice of doing a lot of problems in a methodical way, using the mathematical strategies prepared by Srujana Vidyalaya. It's a piece of cake. Okay, all right. Let me move on. 4.1. There is a 74. You see, look at page 74. The problem number 1. You have two parallel lines. Okay, all right. You have one line here, and there is another line here. Okay, transversal, and there is another line here. Okay. Now they have named a lot of these lines. This is A, X, Y. This is C. This is not a big deal for you. This is E, and this point is M, and this point is N. This point is F, and then next this is G, this is P, this is B and D, this is D, this is Q, H, Q, this is H. Okay, maybe next time what I would like to do is I may use two boards. And then maybe copy the problem, because we want to save some time. This takes maybe a minute or so. Sometimes it's better that I draw it, but if it helps, I may try to copy the problem on the blackboard, prepare it, and then put the blackboard here and do one after another. I will see. I'm not sure, 100%. Okay, here they ask for any 6 point. A point. This is a point, 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 like that. Like that he is asking for any 6 points. Any 5 line segments. Line segments are, this is a line, right? Line segment is this, MN, for example. So here, XM is a line segment. MP is a line segment. Similarly, NQ is a line segment. YN is a line segment. XY is a line segment. Like that, you have the line segments. Now, any 4 rays a point, starting point, and this is ray, right? Ray has a starting point and then extends infinitely. So this is M, E, P, G, Q, H, N, P. These are the, how many are 4 rays? And any 4 lines. 4 lines are, this is like say L, M, this is N, this is say P or K, let's say. So AB is a line, CD is a line, and E, F is a line, GH is another line. That's what it is. So any 4 collinear points. I think I did not touch it. Collinear. Co class means college and also collinear and also what a line with the points. Points which are lie on the same line are called collinear points. So here X, M, P, similarly C, Y, N, Q. All these are collinear points. Now let me move on to the next one, 4.2, 84 page 3, third problem. Okay, I hope you understood this. This is fundamental. This is not very big deal. You can easily know it. So you know a point is a one which does not have any length, no direction, no end points. So here, and a ray has one end point and no length. A line is infinite. It does not have any length. Whereas a ray has starting point, and a ray has a starting point, and finally a line segment. Line segment has 2 end points and it has a definite length. Okay. Now let me see. This is 4.2, page 84. Okay. 84, problem number 3. Okay. Here. I'm copying the problem. So look at page number 84 and problem number 3. Okay. Here I have this problem. There is a line here. This is A, B. Okay, alright. There is a line here. Okay. This is C. These 2 intersecting lines. They intersect at point O. Okay. And here this triangle, he is calling it a small d. And this there is also another line here. This is, he is calling it as E. And now, okay, this is D, and this angle is 40 degrees. And this one is showing different. And then okay, now in the given figure, here he is showing another angle here. Okay, now let me see. In the given figure, AB and CD intersect at O. AB and CD intersect at O. Okay, good. If angle AOC angle B and angle BOE is got 70 degrees. Angle AOC plus angle BOE is equal to 70 degrees. Okay, alright, 20 degrees. And angle BOD is equal to 40 degrees. BOD, angle BOD is equal to 40 degrees. Find angle BOE and the flux of COE. Angle BOE angle BOE and the reflex of angle COE. Reflex angle in a reflex angle after the reflex angle. So this is the reflex angle. Okay. Alright. Let us try to solve this problem here. So AOC plus BOE. AOC plus angle BOE is equal to 70 degrees. Angle BOD is 40. Angle BOD is equal to 40 degrees. And you have to find angle BOE. BOE is equal to and reflex angle is equal. Okay. Now how how do you find it? Now, you see that AB and CD, they are intersecting at point at O. Now angle AOC and angle BOD, they are vertically opposite angles. That means angle AOC is equal to angle BOD because these angles are vertical opposite angles. But AOC is equal to D, and angle BOD is 40 degrees. Therefore, B is equal to 40 degrees. So you know that this is equal to 40 degrees. Now, angle BOD what is some? Angle AOC and BOE is equal to 70 degrees. You know what is this? Angle AOC plus angle BOE. So this plus this is equal to this. These two are equal to 70 degrees. But this one is what? 40 degrees, right? This is 40. So if we take a line here, so this angle 40, this angle is this is also 40. This one we don't know, but they gave angle AOC plus angle BOE is equal to and this is equal to 70 degrees step. So now how do you calculate angle BOE? Okay. Now you see from this angle AOC plus angle BOE is equal to 70 degrees. This is what we call it as given. That's what is given. Now AOC is equal to D, but that is equal to 40 and already you found. Therefore 40 plus angle BOE is equal to 70. Therefore angle BOE is equal to 70 degrees minus 40 degrees. That's not 30 degrees. Okay? So angle BOE, that's the first answer. So this is equal to 30 degrees. Now how do you find the reflex angle, this angle? See here, this is a straight line. So the whole thing is a straight angle. This is how much you got? Divided 30, right? So this is 40. This is 30, 70. That means this should be 110 degrees, right? Because it's a linear pair. So, no, not linear pair. It's a straight angle. Sorry, straight angle. These are like a moon line. This plus this is equal to 180 plus 40. I'm sorry. Let me do that. I think it may be a little bit confusing. Let's see. See, we have to find this angle. So this angle plus this is equal to 180 degrees. So this is 40, this is 30, this is 40. So 70. So this should be 110 degrees. Okay? Alright? Okay. Now let me move on. The next one is 4.3, 95 page. I hope you understood. Okay? Alright. 4.3, page 95, problem number 9. Okay, problem number 9. In the figure, the arrowhead segments are parallel. Then find the values of x and y. So here you have a line. You have one line like that. It's an arrow. There is a point of intersection. There is another line like this that also has the same arrow. That means these two are parallel. Now this angle, now they joined it, these two, and extended. This angle is given as x degrees. This angle is 35. Okay. Now here, this angle is given as 105 degrees, and this angle is given as y. Did I write it correctly? In the figure, the arrowhead segments are parallel. Find the values of x and y. So these two lines, let me now, I'm sorry. Oh, he did not name it. Let me name it, okay? Just for the sake of, this is always, make it the point of intersection always like O. You can call it any, you can designate it by any letter, but it is better you have a common practice. So this is AO. Let me see, this is B. Let's say this is C. This is D. This is E. This is F. Okay, all right. Now, how do I find the values of X and Y? So this is 105 degrees, right? So this is, see that line, see CD and EF are intersecting at point O. That means these are the vertical opposite angles. That is, this angle is 35 degrees. Correct? Now, this is a straight line. So this whole angle is straight angle. 105 plus 35 plus Y. 105 plus 35 plus Y is equal to 180 degrees. This is a straight line. That's a straight angle. Therefore, Y 105 plus 35, 140. Therefore, Y is equal to 40 degrees. I'm not going through all the mathematical steps. So this is equal to, you are 9th class student. I don't think you need that. That's 40 degrees. Okay? Now, this line, these two lines are parallel. This is a transversal. So Y is equal to X. Y is equal to X. This is, what is that? They are called corresponding angles. Y is equal to X because corresponding angle. Therefore, X is equal to 40 degrees. So, got it? Okay. You have to put the proper reason. For everything, you have to write the reason within parentheses, corresponding angle, vertical opposite angle, straight angle, like that, linear plane. Okay? Alright, the last one, that is 4.4 time. 4.4, 103. So, 100 and now we are getting close to finishing it. 103. Find the values of X and Y for which the lines AD and BC become parallel. So we have a line here. We have, the problem is like this. This is, let's call it as D. Okay. Now there is a line point here A. Good. So there is a line. This angle is 30 degrees. Okay. And then he has written a line like this. And then there is a line like that. Okay. Alright. You got it? So this is B. This is C. This is, he is calling it as 2X. This one is X minus Y. Now this is 30 and this one is 5Y. Okay, I think I covered our thing. A, B, C, D, 30 degrees, 5Y, 2X and X minus Y. Okay, alright, okay, we got it. So, here, I don't know whether I'm thinking of using two. Let's say this is a straight angle. This one is straight angle. That means 30 plus 5Y plus this angle. That is angle BAC. Angle BAC is equal to 180 degrees. Also, in any triangle, the angles are whatever. In any triangle, the sum of the angles is equal to 180 degrees. That means it's called angle sum property. Or you can say, in any triangle, sum of all the angles, sum of all the interior angles is equal to 180 degrees. So, so you can see here, now, that means the same angle, angle BAC, angle BAC plus 2X plus X minus Y is equal to, also equal to 180 degrees. I think I am missing something here, thereby you need to, you can use it. No, we did not use the concept of parallel. AD and BC are parallel. That's what we did not, I did not do that. I'm wondering why it should take this much time. Now here, this line and this line are parallel. That this is a transversal. That means this, see, you see the line there. So this line is equal to this line. This angle is equal to this angle, right? So these are the corresponding angles. So 30 degrees is equal to x minus y. And then, and alternative is it? Do you follow that? So this is a straight line. I'm sorry. Okay. What is this point? This point is A, and this is B. So you have two parallel lines. These two are parallel. To make them parallel, what should be the value? So this is 30 degrees. So equal to x minus y is equal to 30 degrees. Okay, got it? Now, and also this x minus y is 30 degrees. So here I made one mistake here. That's why I'm having a problem here. This is 30, but this one, the whole thing is equal to 5y. So if this is 5y, then this should be equal to 2x. So combining these two, combining the equations, you should be able to solve x and y. I may give you a little bit more step-by-step procedure in the next part 3. Okay? Now, for example, here we want to use the concept of two parallel lines at transversal, interior angle, exterior angle, corresponding angles are equal. Then by that we can get that term. But I will tell you in the next second part, next part 3, we will do this problem again and also some of the other problems. Okay? I'm not 100% convinced that you understood the concept here, but here again we use the concept of the two parallel lines at transversal, corresponding angles are equal, and a straight angle is 180 degrees and all that. Okay? Now coming back, let me close this for this portion for part 2, where almost I told you about when lines intersect, they make angles. When the lines are parallel and then they coincide, I talked about the acute angle, right angle, obtuse angle. I also talked to you about complementary angles, supplementary angles, adjacent angles, linear pair. And when there are two parallel lines and there is a transversal, I talked to you about exterior angles and corresponding angles, interior angles, vertical opposite angles, all that. We have given you all the tools, ammunition to solve the problems. So now it's a matter of application of these techniques to solve the problems. So anyway, once again, get the board and try to start practicing solving the problems. If you have a problem, if you could not solve a particular problem, don't stop there. Just scribble on a piece of paper, or just write down page number 74, exercise 4.2, and problem number 3. Tapijaro, can you solve the problem and tell me? So I can guarantee that I will give you my topmost priority to send you the solution. Well, if you like the presentation, share it with somebody, and I'm happy that I could teach this chapter. Next I will move on to, soon after this, I will move on to another chapter. We are on the roll. So, okay, thank you.